Hello youth! Welcome to your video lesson on order of operations, also known as PEMDAS. Some of you maybe even know it as GEMDAS, and we'll talk about that throughout the video. Your learning target today is that I can evaluate expressions using order of operations. So some prior knowledge you might want to get ready to activate is your understanding of exponents and what those do. And a vocabulary word that might come up is product of primes, and we'll talk more about that later also. But remember to do your best, pause here, and think about what do I already know. That's going to make your learning much better, and it's going to make sure that you are activating and engaging with the video lesson. You're not a robot. Don't just copy things down. Okay, so I'm hoping that you have already activated your brain to think about things that you already know, because you already know some things. So this might be a good place for you to just stop and listen, or maybe you want to write down what you think the definitions for these words are first, or maybe you want to write down the charts on the right. Remember though, you are engaging, you're not chasing me to write things down. So, order of operations, PEMDAS. And again, I'm going to just reference real quick. Some people learn this as GEMDAS, and the only reason I say G in GEMDAS is when we get down here, we're going to talk about grouping symbols. The P stands for parentheses, and that's often what you're going to see, but it's not always just parentheses. It's also different grouping symbols. So some common types for grouping symbols would be these parentheses, brackets, braces, fraction bar sometimes can group things together, and the square root symbol. So those are different grouping symbols, and those are intended to group operations that should happen first. So we have a clear order of things generally when we're going through, kind of like a checklist, which I love, that we would do groupings, exponents, multiplication and division, left to right, addition and subtraction, left to right. But sometimes things might come out of order. We might need to add something first, and then we would show that by putting that addition in a grouping symbol. Any of these grouping symbols. Kind of going out of order here. A numerical expression is something you're going to see and hear a lot today. A numerical expression is a combination I should write them down first. A combination of numbers and operations. Okay, what does that mean? It's a lot of vocabulary. It's a little confusing. Just most things what you see, numbers and operations. Operations, adding, subtracting, multiplying, dividing. So an example of a numerical expression, 3 plus 2. I have numbers, I have an operation of addition. Another one, maybe with multiple numerical expressions, 2 times 3 plus 1. So I have multiplication and addition. And we'll talk again about today how many different ways there are to show multiplication also. And then lastly, but not leastly, what we're talking about today, order of operations. Order of operations are the rules to follow when more than one operation is used in an expression. Handwriting is a little bit of chicken scratch on this small screen, but hopefully you are listening too, and you can hear and write what it says. So that's some vocabulary you're going to need to know. Again, having a symbol or chart there might be helpful. Just another chart here for you to see kind of the checklist that is PEMDAS or GEMDAS. Remember, it just shows parentheses there, but it's not always just parentheses. Remember, grouping symbols. A good thing people use to kind of memorize the order PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, is please excuse my dear Aunt Sally. And if that helps you, that's great. What you'll notice here is the emphasis that we are going to do if addition and subtraction show up or multiplication and division show up, we do those in the order of left to right. So addition is not always before subtraction. If subtraction were to show up when we read an expression left to right, if it were to show up on the left, that would happen first. So just make sure that is really pointed out in your notes. And again, you have experience with this, so it's not new. Okay, here are some examples. I'm going to walk you through some important things that might come up. We're going to use order of operations. One quick thing, evaluate, another vocab word. Evaluate means to find the value of, and you'll see that word value right within that word. So evaluate means find the value of. Then it's going to ask us to justify each step. That means we want to be naming what are we doing. What I like to do sometimes, and this is just a strategy for you, is I like to write out my checklist, and I can write it vertically or horizontally so that I know as I go that I've done each step. So I look within my expression here, numerical expression, and I look for parentheses, and I see some. I want to be subtracting 12 and 3 first. So I do that, and you kind of work down in a funnel when you're doing these. This is how I'm going to expect that you show your work. So 12 minus 3 is 9, and then I bring down the rest of it, 5 plus. Check it off my list. I don't see any exponents. There is no multiplication or division, and there's one last thing, which is addition. So 5 plus 9, 14. Oh, I forgot to justify my steps. So right there, I would have written that I did parentheses because that was on my first thing. And then, of course, adding was the only thing left. Next one, evaluate. Find the value of 8 minus 3 times 2 plus 7. Again, order of operations, I'm going to justify. So I could write out my steps, PEMDAS, to help me. I don't see any parentheses, and I don't see any exponents. I do see multiplication. Start getting used to this not being an x. Okay, there are multiple ways to write multiplication. X is not going to be one of them very often because we're going to see algebra, and x is our most common variable. So multiplication will often be with a dot, not a decimal. It will be maybe written next to each other like this, 3 times 2. So get used to that going forward. So we're going to do that first step. 3 minus 2 is 6. Notice I'm going to rewrite. I'm going to rewrite everything else. Not going to be, I'm just going to show all my thinking here. So then I would write down that my first step was multiplication. That was my justification. The next one, I'm going to do subtraction next because that is left to right. So subtract. So here I do 8 minus 6, which is 2. And then last thing, of course, is that I'm going to add, and that is my final step. If you want to justify here why you did that, maybe you can write left to right. So then I get an answer of 9 when evaluated. Last part. Notice again, we have an exponent there. We have 3 to the second power, or 3 squared. What I want you to remember from your previous knowledge from previous grades is that that does not mean 3 times 2. That means a number times itself. So that's written out. I might rewrite this 5 times 3 times 3. But I know that that's what I have to do first because it was the exponent, minus 7. So I know I'm going to do that first. And I get 5 plus 9 minus 7. So again, my justification would be that that was my exponent. I'm running out of room to write down here. Okay, so continuing down then, I see then that I still, oh, see, no, sometimes I make a mistake. So I had to look up, oh, I tried to replace multiplication with addition. Good thing my steps were there because I might not have noticed that otherwise and continued on doing the wrong thing. So important that we work down in a funnel like I have here. So multiplication is next. Check those off my list as I go. So I get 5 times 9 is 45 minus 7. The last thing then would be that I'm going to subtract, and I get a total of 38. These would be great ones for you to try. Evaluate each expression, justify your step. So here I'm going to, again, maybe make my checklist on the side. And I see some parentheses, so I'm going to do that first. 9 plus 4 is 13, and I'm going to rewrite the whole expression, one thing at a time. Easy to find my mistakes later. There's no exponents, there's no multiplication. The last thing is division. Doing 39 divided by 13. Some of you might know that off the top of your heads, but here's a strategy in case you didn't. I know that this is the same as 30 plus 9. And I'm dividing that by 10 plus 3. So what you might notice is that 10 goes into 30 3 times, and 3 goes into 9 3 times. So 39 divided by 13 is also 3. Next one, justify each step. maybe use your checklist. If you haven't, this does say you try, so you should have tried and then come back. If you haven't, pause and give it a go. I see no parentheses, I see no exponents, see no multiplication, but I do see division. Rewrite. 8 divided by 2 is 4. I do see addition and subtraction, but I'm going to do them left to right. So I do 14, and then rewrite minus 6. 14 minus 6 is 8. So again, justifying those steps, either writing them out or having that checklist there. So here's where it says, make sure you're doing this. Pause the video. Do these in your notebook or on this notes template, and then come back and check. Fix any mistakes if you made them. Learn from them. Don't just get it wrong and move on. You can leave your errors there. Don't erase them, but maybe leave enough room to try to do it correctly. Okay, no need to erase. Learn from your mistakes. Go ahead and pause and try. Remember, for this first one here, we have an exponent. So how you show that, this is really 10 times itself 4 times. 10 times 10 times 10 times 10. What I know about multiplying by 10, and I could work down, I know this is 100, then times another 100, and I know that that is 10,000, and I'm multiplying that by 3. Notice how I keep changing that x to a dot to get myself used to it, or to parentheses. So I know that this would be 30,000. The rest of them, I'm not going to give you the answer. I'm going to have you make sure that you do them, showing all your thinking, and I'll check them on your class kick. All right, last one, folks. Applying order of operations to word problems. Oh no, the dreaded word problems. Come on, people. We can all do it. Let's give it our best shot. No stress here. Here's the thing about word problems. I don't read them once and know what to do. Generally, I have to read them at least 3 times to get an idea of what's happening, what am I being asked to do, and then actually do it. So let's read it. Juan goes to the school book fair where paperback books are $1.50 and hardcover books are $3. Juan buys 5 paperbacks and 2 hardcovers. Then it's just giving me the directions. Write and a numerical expression to find out how much Juan paid, and then solve the expression. Okay, so what I gathered is Juan's going to a book fair. Neato. What I probably have to do is read it again and figure out what's going on. So I know that he's going to a book fair where paperback books are $1.50. You know what I think this is missing? I think that they mean each paperback book is $1.50. And hardcover books are $3 each. What that N told me was that he's getting it multiple things. That kind of tells me that I'm going to be adding. This also tells me this word R kind of tells me equals. So I'm kind of thinking, well, paperback books represent also how much, and then it's how much they cost. So that's a representation of each. What I know then later is that Juan buys 5 paperbacks, which I learned about earlier, and he buys 2 hardcovers, which I also learned about earlier. So my job is to write a numerical expression to find out how much he paid. Okay, so we always have something. We have something that's happening, and then it results in something else. So what I just learned, and I might write it out in words first, is that I know that it's $1.50 per paperback book. And, which I know is adding, it's $3 per hardcover book. Okay, well, what I know is that he bought 5 of these. So he got 5 paperback books. And I also know that he got 2 hardcover books. So then what I know is that if he's got 2 of them and he paid $3 for each of them, doesn't that mean we're just doing 3 times 2? And over here, if he bought 5 paperbacks and they were each $1.50, sure, repeated addition, but I could also simplify that and multiply. So my numerical expression here is that, and I could read it back to myself to make sure it makes sense. It's $1.50 for 5 hardcover books, and he got 5 of them, and it's $3 for the 2 hardcover books that he got each. How much total is that? So then I could look and use my order of operations. I see that I have multiplication, and addition. So go ahead and try to finish that and solve. What would my answer be? So when I multiply here, I see that it's 7.5 plus 6. I add those together for 13.5. But I would never answer 13.5 like that because I'm thinking about what the question represents. The question and the answer here is how much Juan paid. So this is supposed to represent money. So then that should be $13.50 was the total Juan paid. That's a deal. All right, you guys are awesome. You can do this. Look back at your notes. Are they quality? Are they going to help you in the future? Check for understanding. Maybe talk about this with a friend or someone at home. Rewatch any section of the video you need to. But remember, it's okay to not have it mastered today. Write down some questions. Put them on ClassKick. Try your best.